So let's solve a question to clear the concepts related to conduction, radiation, convection, and then we'll also touch upon control volume. And when we are solving, we'll require the formula. So we'll also look at the conservation of energy and steady state equation. Okay, so there are a lot of things involved. So look at it. So we are given with a brick wall whose thickness is 0.15 meter and the T1 temperature is unknown to us. So that's what we want to find. Over here the wall K value is given and the T2 temperature or the surface temperature is 100 degree Celsius. Then over here this surface has an emissivity epsilon of 0.8. The surrounding temperature and the upstream temperature of fluid is 25 degrees Celsius. The H value of the fluid over here, it's having the heat transfer coefficient is 20 watts per meter square Kelvin. The K value over here is 1.2 watts per meter Kelvin. So I think all the details are given. What we need to find out is this temperature, and the temperatures and everything or all the details related to heat transfer or energy transfer on this side are given, and we need to find out the energy transfer over here. Okay. So obviously nothing has been mentioned regarding what type of convection is happening. So we'll assume it is free convection. It's not required while solving problem because we will only care about the values right now. But that's a general term. If nothing has been stated, we'll use it as free convection. But that doesn't matter right now. So obviously we want to find out temperature. All the heat transfer occurring is given. Other heat transfer occurring are given. So we'll start with the conservation of energy principle. So whatever energy is coming in minus energy which is coming out or going out plus the energy which is generated is equal to the change in energy of the system with time. Since nothing has been mentioned which is related to time, we'll assume it is steady state. It may not be mentioned everywhere, but since nothing has been mentioned about time related changes, hence we'll assume steady state. Hence the DE system, the change in energy of the system with time will be 0 because there is no change with time. Okay. Now another thing. With what or regarding what will we define the input in or out of the energy or generation of energy? So we'll assume a control surface or a control volume. So we can take any control volume or any control surface, but the easiest one will be to use this surface, the outside surface, as our controlled volume. So this surface is our control volume. That means regarding that, my generation in the surface, the energy generation will be 0. The surface cannot generate energy. That's why the second term, this term, energy generation is also 0. Right? Now what we remain in energy in is equal to energy out. That's the remaining formula for us right now. Okay. What is coming in now? So whatever is conducted from here is coming towards the surface. This is the surface now. Whatever is coming from left towards the right towards the surface is coming into the surface. Over here we know that the surface temperature is higher than the mean temperature of the surrounding, which is 25. That's why that will be from that side we will be losing heat. From this side we are assuming we are gaining heat. That's an assumption. It doesn't matter if we are even losing heat from that side. That means the temperature T1 is less than temperature T2. That will not matter. Whatever will take care will be taken care in the formula. Okay. So now the continuation will be whatever is coming in is heat Q double dot using conduction, and whatever is going out will be due to convection and radiation. Okay, so the conduction formula will be K, change in temperature with change in distance. This is the symbol for flux. So Q double dash is flux. Because the area will be same, that's why we will directly start with flux. Okay, conduction involves H, T2 minus T infinite, and radiation involves epsilon, emissivity, lambda, T surface raised to 4 minus T surrounding raised to 4. Why has this happened? Because since the surrounding is also at some finite temperature, that's why the surface will receive some irradiation and the surface will give away some radiation. So whatever we are receiving is subtracted, or if we take it on this side, we are gaining heat due to irradiation. That's a combined term which I have written for radiation. Now it's very easy. The K value is known to us, which is 1.2. The T is T1, which we have assumed as higher temperature, so T1 minus 100 upon 0.15. H value is known as, which is 20. 100 minus 25 plus 0.8, which is lambda or epsilon. Then lambda is 5.67 into 10 raised to minus 8, and the temperatures are 373. This is very important. This is critical because these are Kelvin temperatures. We need to change them. So this is 100 to Kelvin is 373 Kelvin raised to 4 minus the surrounding is at 25 degrees Celsius. That means it is at 298 Kelvin raised to 4, and so this is 20 into 75, and solving this I'll get 5.203 into 10 raised to 2. So this is 2020.3. Okay, and over here we have T1 minus 100 upon 0.15. That means T1 will be 2020.3 into 0.15 divided by 1.2 plus 100. That means T1 will be, I am getting a value of 352.54 degrees Celsius. So it has come around a value which is higher than that. It may have come, it may be possible, it's possible that the value would be lesser than 100, but that's absolutely fine. Nothing has to be changed inside in the procedure. The things will be same. But over here we assumed that using conduction or through conduction we are gaining heat. That's why I took the conduction in the E in part. We could have taken it in the E out part, but in that case E out means we must assume that the T2 temperature is higher, and in that case if this formula goes over here, it would have been over here. I should have written T2 minus T1, and inherently if I take this term on the right side, obviously 100 minus T1 would have occurred. So it doesn't matter. The only thing is whatever we have assumed, we should stick to it. Over here I had assumed that through conduction we are gaining heat. That means T1 was greater. That means I need to take T1 minus 100. That is higher minus the lower. Over here if I had taken the opposite thing, I would have taken T2 minus 100 or T2 minus T1. So that's the thing. We have solved the problem. In next thing we'll take another problem in next video. Okay, thank you.